guys, so we're gonna start going over the logarithms and compound interest. So first of all, before we start, did you guys know anything about logarithms? Have you looked at them?
Yeah, we did them a little in pre-calc.
Okay, so a little bit of pre-calculus. So okay, so I'm gonna start again, and then we're gonna use the logarithms to solve some equations, which later will be used for finding solving problems related to compound interest. Okay, so last time we talked about exponentials. So if you remember, the exponential was, so if you have exponential functions, so exponential function. Well, that look like this, right? You would take y is equal to b to power x, okay? And so logarithms, that's what we're going to learn today. So they are a way to solve for x in this equation. So if you have here a number and you know what this number is, how do you find this power? Okay, so an example, so the objective today is want to solve equations of this type. So like for instance, I don't know, I have 10 is equal to 2 to power x, okay? And don't tell me that this doesn't have a solution because there is no power of 2 which is equal to 10, because it turns out that there is. So this is an equation, so we want to solve for x. So maybe I should say here, solve for x. Okay, an equation like this. Well, the solution for this, yes?
I have a quick question. Like, let's say, like, if we have this problem, will we need to also use a calculator for some of these, or to figure
For
out?
some of them, if you want to write the equation in terms of a number,
Uh-huh.
like a decimal number, then yes, but usually you can write it as a logarithm, and I would prefer it like that.
So x equals, and then the answer in terms of logs, right?
Right,
Like log
that's right.
2 over log 3
Right.
or something, right?
So
Okay.
if you write a decimal number, it's not going to be helpful for me.
Right. Okay.
Okay. So now if I want to solve this, well, okay, so here is basically, let me try to explain what is the solution. The solution is x, right? So it's the power that I need to raise 2 to get 10. And that has a name that's called a logarithm. So x, in this case, is called a logarithm of 10 with base 2, right? So again, so whenever I have an expression of this sort, what this means is that x is equal to the power that I need to raise 2, which is the base, to get 10. Okay, what's inside the logarithm, what the logarithm of which number I'm taking. So in general, so if I have, let me write the definition here. So so if I write logarithm of number a with base b, right? That's the power, is the power b needs to raise to be raised to obtain a, right? So b, so if I have that, this is like, this is called, let's call this x, right? So that this thing here, this equation here, is the same thing as saying that x is the power that I need to raise b to obtain a. So in other words, I can write this equation is the same as if I wrote that b raised to power x is equal to a. Okay, so, so that's the same thing as saying that x is logarithm of a with base b. So so this, maybe I should write it here, so I can write that this is the same thing as saying that x is equal to logarithm of a with base b. Okay, so those two things are the same thing. There are different ways of writing the same thing. So let me write that again. So I have b to power x is equal to a is the same thing as saying that logarithm or x is equal to logarithm of a with base b. Okay, so those are the same things. So in particular, the way you can think of this one here, you can say, okay, let's take logarithm of both sides of this equation. So I will have logarithm of bx, b to power x, with base b, and that's the same thing as logarithm of a with base b, right? So you can think that you obtain this one here by taking the logarithm of both sides of this equation here. So the logarithm of the left-hand side would be this, and logarithm of the right-hand side would be this. Okay, so but that we saw that this one here is equivalent to that. So this is saying that the left hand sides of this and this are the same, because the right hand side are the same, right? So the right hand sides are the same. So this is saying that I have that this is equal to x. Okay, so that's one of the um, properties of the logarithm that we will learn in a moment, that logarithm of b of any number you want, let's call it a to power, or let's call it c to power x, is the same thing as just taking this exponent and putting it in the front. So that would be the same thing as writing as x times logarithm of c with base b. Okay, so that's one of the properties of the logarithm. Okay, so that's the definition of the logarithm. Again, logarithm of a with base b is the power that I need to raise b to obtain a. Okay, so that's the definition of the logarithm. So let's take some examples. Okay, so for instance, I can take what is the, let me take some examples from the book. Right, so for instance, I can take logarithm of 100 with base 10. What's that? Well, that's the power I need to raise 10 to obtain 100. And of course, that's 2, right? 10, because 10 squared, right? Because I have that 10 squared is equal to 100. So that's the power that I obtain as the logarithm, right? Okay, so here is a trick you can remember. So the trick is just to write that logarithm 10 of 100 is the same as logarithm 10, and then inside, instead of 100, I'm going to write 10 squared. So that's going to be so I'm going to put this power in front. So that's going to be 2 logarithm 10 10. Okay, and then okay, so then the question is, what is this number here? Well, that's the power I need to raise 10 to obtain 10. What power do I need to raise a number to get the same number? That's power 1, right? If I raise any number to power 1, I get the same thing. So this whole thing is equal to 1. So this thing here is equal to 1. So the whole thing is equal to 2. So what that means is if I have logarithm of 10 of something, if I raise that 10 as some power, then that power is my logarithm. That's my answer. So here is another example. Let me make this a little smaller. So I have logarithm of 5 to power, let's say 125. Oops. Right? So that's, so essentially what I'm asking is what is the power of 5 that is
Wait,
equal to
wait, quick question.
125? Yes?
You put equals 2,
Right? Where?
for
Oh,
log
right. Yes,
base
yes.
of, isn't it 1?
So just the logarithm 10 with base 10 is 1, but then you have this 2 in front, right?
Oh, I didn't even see that. My fault. Sorry.
Mm-hmm. Okay, so that gives you that this is equal to logarithm. Let's do the same trick and write 125 as the power of 5. So that's 5 to power 3, right? Because it's 5 times 5 times 5, right? 25 times 5 is 125. So it's 5 to power 3. So it's equal to that power. So it's equal to 3. Okay? So another example is logarithm of 3 of 1 over 27. Okay? So what is that equal to? So we need to figure out what is 1 over 27. So 1 is over 27 is 1 over 3 to power 3, right? Because 27 is 3 to power 3. So that means I can write this as 3 to power negative 3. So I can write, if I write this upstairs, so I'll have logarithm base 3, and then I write 3 to power negative 3. So the answer is the power I have here. So it's this power here. So it's just negative 3. Okay. So next, I'm going to write down some laws, just like in the case of exponentials. We have laws for logarithms, which make it easy to calculate the logarithm for more complicated expressions. So before we do that, I want to do one more notation. So logarithmic notation. Let's write it like this. So logarithmic notation. So there is two situations where a logarithm has a special notation. So one of them is this one here. So if I write logarithm with no base of some number x, well, that's just the shorthand notation for logarithm with base 10 of x. Okay, so this is just a notation. And another one is you write logarithm ln x, and we haven't talked about it, but this is this number e, which is famous, e to power x for exponential. So this is a logarithm with that base e x. So here where e is the 2 point is approximately 2.78, etc. So I'm not gonna tell you probably if you don't know what this is, but this is called a natural logarithm. Um, so we don't have really time to talk why it's important, but in a lot of situations, that's the most natural thing. So one of the things, if you remember the way to figure this, what this e is, if you remember what the graph of exponential function was, so if you had several different exponential functions all going through the point 1, so we had this one maybe here, and let's do this one here, right? So let's say there is this is the graph of 3 to power x, and this is the graph of 2 to power x. Well, as you note here, this e is a number between, this is 2.78, this is a number between 2 and 3. So what's the significance of that number? One of the things to know is that if you look at the slope of the graph here, you get different numbers for these ones here. And e is the number for which the graph, if you draw the graph of this thing here, so let me make it green. Okay, so this is this graph of e to power x. It has the property that if you now look at the tangent line at this point, then the slope is equal to 1, right? So the slope of the tangent line at 0 is equal to 1. So e to the x, so let me just write that down. The slope of e to the x at the point 0, 1 is equal to 1. Okay, so that's the significance of this, and there is just this number, this e, that's how you can find it. Okay, and there's many other ways and reasons this is important. Okay, this is notation, so it's not as important as what I'm gonna say next. So those are next I'm gonna just write down some rules. Actually, I'll do it on the next page. So rules of logarithms. So laws of logarithms. Okay. So what are these laws? One, if you have logarithm with base b of m times n, that's the same thing as logarithm with base b of m plus logarithm with base b of n. 2, the same thing but for the ratios, m divided by n is logarithm b of m minus logarithm b of n. 3, logarithm b of m to power n, right? So this is what I was telling you before, that this exponent comes to the front. So so that gives me n times so n times logarithm with base b of m, and I have 4 logarithm. The first one both is m. No, the first one is m and n. So I don't know if you can see this, but so this is n, and this is n as well. Is that visible now? Okay. So the next one here is, okay, so logarithm of b with base b of 1. Okay, so let's think about this. What is this? This is the power I need to raise b. This, like, think of b as, say, 2, right? So if b was 2, this would be, to which power do I need to raise 2 to get 1?
0.
0, right? So it's 0 power. You take any number, you raise it to power 0, you get 1. So logarithm of 1 is always 0. And then the last one, logarithm of b with base b, that's just which power of b is b.
It's the
It's
same thing
the
as b.
first power, right? Power 1. Right, so those are these rules which are going to be important to do all kinds of examples. And
If you had log base 27 to the power 27, it would be 1, right?
yes, right, so any b, no matter what b is.
As
And
long as
of course we're taking, b's are positive numbers, so b, always b is a positive number. Could be 1, that's fine too. Okay, of course 1 to power some power is always 1, no matter what power this is. This is my daughter trying to come into the room. Okay, so let's do some examples now. So here, some examples. Maybe I can just do it next to them, so next to these rules. So I do, for instance, logarithm of 2 times 3 is logarithm 2 plus logarithm 3, right? This is logarithm. Remember, if I don't have a base, that means the base is 10. But that's not important. I could write any base here. Another example is logarithm of root 7. So that means what? This is, what is root 7? Root 7 is 7 to power 1/2. So okay, so now by this rule here, number 3, by rule number 3, I can always take this power and put and write it in front. So it's going to be, right, so take this and put it in front. So that's what I'm going to do, take this and put it in front. So the answer is going to be 1/2 logarithm of 7. Okay, so let me take more interesting examples. So let's take so here, actually, let's do some examples I have here. So express the equation in logarithmic. So let's do number 1. Express the equation in logarithmic form. So this is 3 to power 4 equals 81. So if I write this using logarithms, this is saying that 4 is the power to which I need to raise 3 to get 81, right? So this is saying that 4 is equal to logarithm of 81 with base 3. Okay, So that's another way of writing the same equation. Let me write it different. Let me deduce this differently. Let's start with this again. I'm going to write it here. 3 to power 4 is equal to 81. Then I'm going to take logarithm of both sides. So I'm going to write logarithm of 3 to power 4. Let's do base 3. Okay, so that's going to be logarithm with base 3 of 81. Okay, but then what does my law say about the powers? These powers go to the front, so I can write this as 4 times logarithm 3 base 3, and again logarithm of the number with the same base is 1, so this gives you 4, because this part here is equal to 1. Okay, so that's another way of doing this thing. So
But
we get that.
confusing though.
Yes. Huh?
Isn't this way confusing a little?
I don't know. Let's actually do it a couple of more. Then maybe I do
Yeah,
this
could you do another
again.
one?
Hello. Yes.
Could you do another one?
Yes, I'll do another one. So let's do the same thing. Let's actually do this one more time, and then I'll do again. So 3 to power 4 is equal to 81. So I take logarithm of both sides, right? So with base 3, and all you have to remember is that logarithm of 3 and 3, so if these two numbers are the same, kind of this whole thing cancels out, and all you have left is just 4. So the answer is going to be, and also it's from the low, right? The 4 comes to the front, so it gives you 4 is equal to log of 3 with base 3 of 81. Okay, so let me do another one here. How do you know the base is 3? Because this is the base here, right? I want to find this power here, so I want to find the power of 3. So I have, if I want to get rid of this 3, I have to take the logarithm with base 3. Okay, does that make sense? Let me do another one.
But is it okay if you like memorize the formula and just put the numbers in place?
What?
Like, let's say you know the formula, like you'd have to do this way, like.
If you know that this is, no, I mean, this is just an easy way. So let me do another one, and you try to see what, if you like it or not. Okay, so let me do, I don't know, 64. What is 64? 64 is 2 to power, actually let's do it like this. So if I take 2 to power what, 6, right? Or no, right, 6 is equal to 64, right? So that means what? That means 6 is equal to logarithm with base 2 of 64. Okay, so, or you can take, let's do it again. So let's do it differently again. So I take logarithm of 2 to power, logarithm with base 2 of 2 to power 6 is logarithm base 2 of 64. But this whole thing on the left hand side is just 6. So 6 is equal to logarithm base 2 of 64.
Okay, I just don't get that extra step. Like, why do we have to do that? If we could just write it like 6 equals log 2 base 2 4 to the 64, it's like.
Okay, so let me do it like this, right? So I mean, maybe you don't need that.
I mean, I understand what you're doing, but I'm just saying, like, what's the point of doing that? You could just go straight to the answer, you know?
Yeah, I mean, sometimes maybe not in this example, but many times it would be
I guess it depends on
useful.
the example, yeah.
Huh? Yeah, the whole point is that what I'm trying to do is to show that it's useful to take logarithm of both sides of the equation.
Right,
And
right.
we'll see that in a moment again. So let's do the same thing here on this example. So on this example here, so I take, how do I do this? So I take, if I now do logarithm of, or actually let's just do it as you said. So it's -2 is equal to logarithm with base 1/2 of 4, right? So this is what this equation means, because this thing here says that -2 is the power I need to raise 1/2 to get 4. Okay, so without extra steps. Now, okay, so here is another example. We need to calculate logarithm 5/2 if we know logarithm 5 and logarithm 2. So we use this one of the laws, which was logarithm of the ratio is the difference of the logarithms. Okay, so
If your base is the same, you could just subtract them.
what?
If your base is the same, right? So you could just subtract the logs and you get the answer.
That's right, that's right. I mean, whenever you have a ratio, then you have the same base. And in this case, actually the base is 10 because it's just not written there, so that means it's 10. So that means this is approximately equal to 0.6990 minus 0.3010. So this is, it means that it's approximately 0.398. Okay, so oops, sorry about that. Okay, so next example is this one here. Write the expression as the logarithm of, wait, okay, wait, I'm waiting. Should I show this again? Sorry guys, let me just tell them so that the Skype doesn't, how did you calculate it? Just a second. Okay. Okay. Oh no, was there a question? How did I get which part? So I'm just, the only thing I'm doing here is I know that this is equal to this minus that. Was that clear? Oh, this was given to us. So the question is, suppose that you know logarithm 5 and logarithm 2, find the value of the logarithm 5/2. So the fact that this and this were given to me, it's just given to me, okay? Or if you have the calculator, yes?
In the other two questions, why do you put the base on the right side also?
On the right hand side in here.
Yeah.
Okay, so that's a
And
good question.
like, why is the 3 by the 81?
Right. So because so the question is, let me take a different example. Okay, so let me take something which doesn't have numbers. So if I have, for instance, an equation like this, x is equal to, I don't know, 2y, 2y, right? Something like that. Now I'm taking logarithm of both sides. If I take logarithm of this side with base 2, then this side also will have to be with base 2. It's like
Why?
it's like taking a power, so base 2. Okay, so it's similar to this. If you have that, so you have an equation, maybe x is equal to square root 2, or actually let me write it like this. Suppose you know x to the 3 is equal to 8, right? How do you solve this? You take 1/3 power of both sides, correct?
Yeah.
Why?
Yep. No, that's good. Yeah, that makes sense.
Right, because you have to do the same thing to the both sides.
Yeah, that makes sense.
Okay.
Okay, fine.
Okay. So I wouldn't take one square root on one side and third root on the other side. It's a similar thing to this. Okay, so write this expression as the logarithm of a single quantity. So here I'm going to simplify this a little bit using these laws. So I'm going to first write this one here. If you remember, I can write this as logarithm, natural logarithm. Now I have a 1/2 here, so I can write that as a power of x. So it's x to power 1/2 plus, question? Then I have the same thing here. So all of these things, this is a power, this is a power, it goes here, and then this one is a power and it goes there. So I can write as logarithm y to power 4 minus logarithm z to power 3. Okay, now I can write this using these addition and subtraction rules. So if it's logarithm x, so these two things together, what's that? That's logarithm of x to power 1/2 times y to power 4, correct? And then I need to subtract logarithm of z to power 3. So I can write this. Okay, so it's logarithm of x to power 1/2 times y to power 4 divided by z to power 3. Okay, so because the subtraction becomes the quotient. Any questions about this? Should I go over it one more time? Okay, so let me just do it quickly one more time. I have this plus that minus this. Okay, so I simplify all of this and write them as logarithm without coefficients. How do I do that? Well, I make the coefficients into powers. Okay, so then this becomes x to power 1/2, this becomes y to power 4, and this becomes z to power 3. Okay, so then I have logarithm of this plus logarithm of this minus logarithm of that. So I can write logarithm of this times that. They multiply because I have an addition here. And then I have minus this part here. So I have divided by this. Okay, so that's how I got that. Okay, what about the plus sign? Right, so the plus sign, okay, let me just remind you. So logarithm of a plus logarithm of b is equal to logarithm of a times b. I'm using that law. So this plus sign disappears, and instead what I get is this multiplication, and these two things are inside the same logarithm. Does that answer your question? Okay, so on the similarly I have logarithm of a minus logarithm b is logarithm a divided by b. Okay, So that's why I don't have the minus sign also. Okay, so next, so in these examples, this was the natural logarithm, base is e. Okay, so next let's use the logos of logarithm to expand and simplify this expression. So I'm going to write this as, now see, I have a fraction, this divided by that. So I can write this as a difference. So I can write this as logarithm of e to power x minus logarithm of 1 plus e to the x. Okay, so this one here I can't really simplify, but this one here I can. Okay, because let me,
This
yeah,
one. Why can't you simplify 1 plus e to the x?
because it's like it's a
Expression?
yeah, it's like 1 plus x squared with a square root. I can write, I cannot do it like square root of 1 plus square root x squared, right?
Separate this, right?
Huh?
You can't separate 1 plus e to the x, right?
Right, I cannot like separate. This is logarithm of this sum. It's the argument of that function of the logarithm, right? So
Ln e, isn't that just 1? Or no? Or is that x ln e? Or no?
this one,
No, the left. Isn't that
this
just e?
one. Oh,
Yeah.
I'm going to do that in a moment. This one I cannot, but this one I can simplify.
Oh, okay.
So that's just x actually. So this is equal to x. Because this is what? Remember, logarithm, natural logarithm is logarithm with base e of e to the x. So this e's and these e's kind of disappear, they cancel, and all you have is just the power which goes to the front. Okay? So you get minus logarithm 1 plus e to the x. So this is equal to, if you want, I can write it like this, x times logarithm e base e minus logarithm 1 plus e to the x. Okay, so this is just x. Did that make sense? Is it clear how I got this? No?
Not really.
Yeah, let me just do this again. So let's do that part. So if I have, it's like we were doing logarithm base 2 of some power, right? Let's do 5. What's this? This is 5, right? Because this is saying what power do I need to raise 2 to get 2 to power 5? Well, it's just 5. Okay? Similarly, I can do logarithm of 2 to x, that's just x. Or logarithm with any power b of bx is just x. Is that clear, everyone?
Yeah.
That's clear. Okay. Well, this thing here is an example of that.
Yeah,
right?
now I see that.
Okay, so that's just, instead of b, I have e. Okay. Okay, good. So next, next is the important thing. Now, next we're going to use these logarithms to solve equations. So this is the first equation we're going to solve. It's very easy. So we have, let me make it bigger. So we have 3 times e to power t minus 1 is equal to 3. So if I solve, well, first of all, I can cancel the 3's on both sides. So I'm going to do e to power t minus 1 is equal to 1, right? I canceled both sides.
By 3?
I divided by 3 both sides, right? So next, I'm going to do logarithm of both sides. And of course, which base should I use? I should use this base here, right? What?
Why do you choose that base?
ln, right? or no?
Yeah, there is no other base here, right? So I want to find t minus 1. So if I want to take this, then to get rid of this e, I have to take the same base. Okay? So because I want to write logarithm, let's write the e of e to power t minus 1, and that's equal to logarithm of e of 1 with base e. Okay? Is it clear how I got from here to here?
No,
I just the logarithm of both sides.
could you go over it one more time?
Which part? This last part?
Yeah, no, the whole thing.
The whole thing?
Yeah.
Well,
Wait,
okay.
wait, I have a
So,
question. Use
yeah.
ln.
What?
Can't
Yeah,
use
this is ln. This is like regular ln. I can write it as ln.
Oh, so you can just write ln e to the power t minus 1 ln 1, right? Equals ln 1.
Right, yeah.
There's another way to do it, basically, right? Or just
I mean, it's just a different notation. I just didn't want to use the ln notation.
oh, okay.
Okay, so okay, so Mohammed, since you asked, so going from here to here, I cancel the 3's on both sides, or if you want, I divide by 3 on both sides, so I get this equation here. Okay, then I have this equals to that. So I want to take logarithm of both sides. So see, this is that, and this one is this one here, right? So I just write logarithm of e in front of both sides. Okay, and the thing is that this simplifies quite a lot, because this thing here is the same thing as just the power. Okay, so this is equal to t minus 1.
Hold on. Mm-hmm. So, which one's your answer? Log. Hold on. You know these dumbass people keep calling me. Repeat that again.
So I have, it's similar to when you have two things. It's like,
No, the
okay,
last
so
page, is that the answer? Like log.
not yet. I'm not done yet. Almost done, but not done yet.
Oh, then finish.
Okay, so logarithm e of 1 is what? 0. So t minus 1 equals 0. So t is equal to 1. That's your answer.
Okay.
Okay. So let me do another one like this.
Wait, could I copy this one? Or
Okay.
give me a second. I get it down.
Okay, so are you done?
Yeah, I'm done. You're good.
Okay, so here is a similar equation. Let's do it. Let's do this one here. I have 2 times 3 to power t plus 5 equals 6. Okay, I want to solve for t. How do I do that? Well, first of all, I'm going to simplify, and on the left hand side, I'm going to leave just the exponential. So I'm going to divide both sides by 2. So I'm going to get 3 times 3 to power t plus 5 is equal to 6 over 2, right? Which is 3. Okay, so that's my new equation. 3 to power t plus 5 is equal to 3. Now I want to solve for t plus 5. Actually, this is too easy. Let me just change it a little bit. This may be confusing. Let's make it 7 instead of 6. Okay, so this is 7 over 2, because I divide both sides by 2. So I get 3 to power t plus 5 is 7 over 2. Okay? So next, to solve this, I take logarithm of both sides, and I'm going to take, since I want to get rid of 3, I'm going to take logarithm with base 3. So it's going to be logarithm with base 3 of 3 to power t plus 5, and that's equal to logarithm with base 3 of 7 over 2. Okay? Now, what's the left hand side? The right hand side I cannot change at all. It's gonna stay like this. Okay, so this I cannot change, but I can use a calculator to calculate this. This one here I can simplify, is just equal to t plus 5, right? So I get that t plus 5 is equal to logarithm base 3 of 7 over 2. So my answer is going to be t is equal to logarithm 7 over 2 with base 3 minus 5. Okay, does that make sense? Yes. Sorry about that, guy. Okay, so any questions about this?
No.
Okay.
But again, we don't have to use log, right? We could also use ln.
You could, yeah, but then it would be more complicated. See, the answer, if you used logarithm with natural base here, you would have a more complicated answer, because because yeah. So sorry. So this logarithm base 3, and if I took logarithm with base e here, then I couldn't get rid of this whole expression, and then I would have a more complicated thing here. So I need to have the same base to get rid of this expression, so that I can have just t plus 5.
So you're saying whenever there's an e in the actual problem, then you can use ln, right? Because that cancels to just 1.
That's right, yes.
Okay.
Okay.
So, quick question on the last one.
Yeah.
For the, where'd you get the 1/2 from?
Oh, I'm trying to keep the exponential part on the left hand side, so I'm getting rid of the constants. I'm putting all the constants on the other side.
Okay, so you're basically solving. Okay.
Right, so I'm trying to solve for this exponent first, for the exponential, and then just the exponent.
Okay.
Okay. Okay, so use logarithms to solve the equation. So we have a couple of more equations. I don't think I'll do the other ones, just this one here. Okay, very similar. So use logarithms to solve the equation for t. So I have 20 divided by 1 plus 2 to power e to negative 0.6 t equals 10. So let's try to solve. Okay, so again, I'm gonna try to solve for this term first, and then find t. Okay, so let's find this term. So if I cross multiply, I'm gonna get what? I'm gonna get 20 is equal to 10 times 1 plus 2 times e to negative 0.6 t. Okay, and so I'm gonna divide by 10 both sides, so I get 2 is equal to 1 plus 2 e to negative 0.6 t. and then I subtract 1 from both sides. So I'm going to get 1 is equal to 2 e to negative 0.6t. And then if I divide by 2, I'm going to get 1/2 equals e to power negative 0.6t. Okay? So this was simple algebra. I didn't do any logarithms. I just solved for this term here. And now I need to take logarithm of both sides. And now because base is exponential, I'm going to take the natural logarithm. So I'm going to take natural logarithm of 1/2. It's equal to natural logarithm of e to negative 0.6t. And this thing here, natural logarithm of e is 1, so it just gives you the power. So it's negative 0.6t. So the whole thing becomes logarithm 1/2 is equal to negative 0.6t. And then if I divide by the, so then I solve for t, right? So t is equal to 1 over negative 0.6 times logarithm of 1/2. Okay?
I have a question about your cross multiplying.
Which part?
Your cross multiplying, like at the beginning.
Yeah.
I don't really use that. It would have been normal if I just did. I just canceled out the 20 first, and then went through it after that.
Right. As long as you get the same thing, it doesn't matter how you do. You can cancel out 20 if you want, and then you write that the denominator is equal to 2.
Okay. Okay. Okay.
Okay?
Mm-hmm.
Okay. So before we finish, let me do some more examples which actually will be useful for compound interest. Okay, so let me skip these 2 examples and do this one here. So here's an equation. So this equation here is essentially the formula for the compound interest. We'll talk about that later, next Tuesday. But
Wait, I'm sorry.
don't.
What was the answer for the previous question?
Oh,
I'm sorry.
it was this one here.
Okay, I don't really. What did you exactly do? You just divided it?
Yeah, I just divided by negative 0.6.
So
I mean, we can write it simplified, of course. We can write it that this is equal to negative, right? Uh,
because I don't know if how on the homework they want it. Do they want it like simplified all the way, or they want it? We can leave it like this.
no, you can leave it like this, but there's not going to be a homework.
I know, but I'm still doing it because I want to like.
Oh, okay, okay, yeah. So in the simplified form, you can, if you want to simplify, then you can write what is this, negative 0.6. So it's 10 over 6, whatever that is. And then logarithm 1 over 2, you can write as negative of logarithm 2. So then this will become plus, and then you'll have a logarithm 2 here.
Okay.
So then this is 5/3. So the answer, you can write that as 5/3 logarithm 2. Do we have to do homework? No, not 5.1, 2, and 3. You don't have to do. Was there a question? Oh, Nona had a question. I have a question. The line 3. Which one's the line 3?
The one was 1 plus 2.
This one? Oh, no, this one?
Lo que es ser mamá y estudiante al mismo tiempo.
This one? Or this one?
Bien, mamá, está en la casa.
The one which starts with 2. Okay. So to go from here to here, you just divide both sides by 10. So you get rid of the 0 here and 0 here, you get 10, and then you get rid of the parentheses because it's 1 times this.
Puro bebé.
Right, so you get 1 plus 2 times that. So you subtract 1 from both sides.
Besito.
So you subtract 1. You get rid of this one here, and then you get 2 minus 1. So you get this one here. And then you divide by 2. Divide by 2. Multiply by 1/2. You get this one.
Yeah. Information Specification
Okay.
and Intelligence Automatic Specialty.
Okay, so
Competition.
let me do just this one problem and we'll be done with it, okay? So see, this is a problem that you see in compound interest. So it says 15,000 equals 10,000, 1 plus 0.06 to power t.
Online
So
lesson.
let's divide both sides by, so divide by 10,000. So you're gonna get 1.5, right, on the left-hand side. 15,000 divided by 10,000 is 1.5. So that's equal to, here you don't get anything anymore, so it's 1. And then you get 1 plus 0.06 to power t, right? Which is 1, I don't know why I wrote it like this. It's 1.06 to power t. So one way to solve this, this is what is it, 1.06 to power t. Okay, so you can do it like this. You can take natural logarithm of both sides, or you can take logarithm with base 1.06, but that's not nice. Okay, so that's hard to compute using a calculator. So I'm going to take logarithm with natural base. So logarithm of 1.6, 1.5 is natural logarithm of 1.06 to power t. But that's equal to, this power can come to the front. So that can be written as t times natural logarithm of 1.06. Okay, so I can write this as, so t is equal to logarithm 1.5 divided by logarithm 1.06. So that's a simple equation that you can solve like that. And so if you want the applications, what this is saying that is, if you have, if you invest $10,000 and you the account gives you 6% annual interest, then the question is, at what time will there be $15,000 in your account? And the answer is given by this formula here, right? So this is the time needed for a 6% interest account to grow from 10,000 to 15,000. That's the application. And then we'll do another one next time. Okay. Any questions about how I solved this or no?
No.
Okay, so let's stop here then, and I'll send you information about the.
Wait a minute. Hold on.
Yes.
Isn't it? Don't you have to do it by ln e? Added both sides, multiply ln e on both sides. Why just ln?
Ellen, you don't have, see, You don't have an exponent. That's okay. So are you confused because there is no e here?
I mean, yeah, isn't that how it's supposed to be? Like,
Right. So, but what I could have done is I could have taken logarithm
I mean, they
with
can't.
base 1.06, but you can do it with logarithm. We could do logarithm base e even if we don't have e. So that's how it's done here.
But the ln's, don't they cancel out anyways?
No.
ln, like, let's say if you multiply by both sides ln e, isn't that 1?
I'm not multiplying.
I mean, you're adding it on both sides, like.
I'm not adding. I'm taking. It's like taking a square root of something, right? So you
Yeah.
have two things which are equal to each other. You can square them, and the answers will be the same. Or you can take square root. The answer will be the same.
Final exam.
So is that clear? So that means I can take the logarithm of both sides, and it still will be the same.
Okay.
So so the point is, no, I cannot cancel these things. It's imagine if I had square root of 25 divided by square root of 36. So can I cancel the square roots?
No.
It's the same thing.
Right.
So if you want, I can write it as parentheses here. Okay, so you take logarithm of 1.5, you get a number, and then you divide by logarithm of 1.06, which is another number.
Right. And
okay?
then you right.
So I cannot do just 1.5 for 1 over 1.06. Just like in this case, this is not equal to 25 over 36.
Right. I understand.
Yeah, makes sense? Okay. Was there another question? Okay, so I'm gonna stop the recording. Was there a question? Oh, no. Yes, ask your question. Is it about the recording? I didn't have the time to send you the recording. No, I didn't send the recording. I'll send both today's and Tuesday's recordings. Okay, so I'm gonna stop recording today, and